In this video, we're going to tackle finding implicit derivatives. These are equations that have x's and y's that can't be separated to be y equals equations where we could find the derivative using our normal rules. Rather, the x's and y's are both part of the equation and we can't break them apart. If this video helps you, please like and subscribe for more calculus help. So to begin with, we're going to use all the rules we've already been using. So if x squared plus 5xy plus 3y cubed is 9, we're going to find the derivative. Well, we're going to begin by just finding the derivative of x squared, which is 2x. And now you'll notice we have a product. We've got 5x, and we've got that multiplied by y. So we have two functions being multiplied together here. So we have to use our product rule. So we're going to do first times the derivative of the second, and the derivative of y we just write as dy over dx. We're basically using chain rule here. We're saying y is a function. We don't know the derivative of it. Or we don't know the value of that function, so we're going to just mark it as dy dx. Plus the second, which is y, times the derivative of 5x, which is just 5. I'm going to put that up front. The derivative of 3y cubed. Again, remembering that we're basically doing chain rule here. We're going to treat y as a function and kind of do the chain rule around it. So we've got power rule brings this to y, this, and we have y squared. And then we have to multiply by the derivative of the function y, which we don't know. So we just write dy dx. On the other side, the derivative of 9 is just 0. At this point, because our goal is to find dy dx, we're going to separate this our derivative pieces here into dy dx stuff and non-dy dx stuff. So, of course, we have two terms here that have dy dx's. I'm going to choose to leave those where they are and move the other non-dy dx stuff to the other side. So I'm going to subtract 2x, and I'm going to subtract 5y. And then at this point, on the right side, I've got negative 2x minus 5y. And over here, I am going to factor, since both terms have a dy dx, I'm going to factor it out and leave me with 5x plus 9y squared. And then, because, again, the point is finding dy dx, I'm going to divide both sides, 5x plus 9y squared. And there is my derivative. Now I'd urge you to pause right here and try this one that I've just dropped in. I'll show my work in a second. Again, if this helps you, please like and subscribe. I've got lots more calculus help, including entire playlists on calculus. Let me show you how I would do this problem. I would start by saying that this first piece is a product of two functions, 4x cubed and y cubed, 4x squared, and y cubed. So I would say the first times derivative of the second. Make sure and use your chain rule. So 3y squared dy dx plus the second, y cubed, times the derivative of the first, which would be 8x. So I've done my product rule. Then I can move on. The derivative of 3x squared is 6x. And the derivative of y to the fourth is 4y cubed dy dx. Again, chain rule is the reason for that. Now I want all of my dy dx stuff on one side and my non-dy dx stuff on the other. Because one thing is already over here on the right side with the dy dx, I'm going to choose to move this over to the other side. And I'm going to clean it up a little bit at the same time, because 4x squared times 3y squared is equal to 12x squared y squared dy dx. So I'm going to subtract that off. So I am left with 8x y cubed plus 6x equals, I'm going to factor that dy dx out. So dy dx is out of both. 4y cubed minus 12x squared y squared. And I'll then divide both sides by 4y cubed minus 12x squared y squared. So there is my derivative. Again, if this helps you, please like and subscribe, and check out my playlist for more calculus help.